before the Big Bang? That's the million-dollar question, right? Well, in this video, we'll survey 10 mind-blowing ideas currently being proposed by some of the world's leading cosmologists. The question of what came before the Big Bang was often thought to be a meaningless one because Penrose and Hawking proved that the Big Bang was an infinitely dense singularity, marking the very beginning of time. Game over, right? Well, not so fast, because in the 21st century, most physicists ended up rejecting the singularity, including Penrose and Hawking themselves.
It is certainly a view quite commonly expressed now that we shouldn't simply give up that the Big Bang is a singularity, that we need a theory which describes that. Most people would say it's a form of quantum gravity. I have a view which is different from that, but nevertheless, I have in common with that we need a new theory.
The real lesson of the singularity theorems is therefore that we need to combine the general theory of relativity with quantum theory in order to understand the origin of the universe.
I don't think anybody believes that the universe started off with the singularity. That just tells us that Einstein's classical theory of general relativity breaks down. So that classical theory of gravity doesn't apply when you get to very high energies.
Now, obviously, this is going to be a brief video, but if you want more detail, we have a book on the subject that's just come out, The Battle of the Big Bang, co-authored with the award-winning cosmologist Neayesh Afshordi. In fact, Neayesh and I surveyed physicists on controversies within the field, and out of 12 questions, the only one they agreed on was that the Big Bang does not imply a beginning of time, only that the universe evolved from a hot, dense state. So what on Earth, or beyond, could have happened before the Big Bang? Our first contender is by far the most popular: inflationary cosmology. Imagine a tiny seed of empty space filled with a repulsive gravity material that expands at a stupendous rate. When inflation ends, it heats up the universe, giving us the Big Bang we know and love. But because it's a quantum process, it doesn't end everywhere at once. Some regions keep inflating, spawning more Big Bangs ad infinitum. The scheme is known as eternal inflation, and it's why many think we live in a multiverse. This may sound like science fiction to some, but to others it's a necessary consequence of our leading theories. No surprise then that it's caused a lot of controversy within physics, something that we examine in detail, talking to both opponents and supporters in the book. If inflation happened, we still want to know what set it off. Enter Stephen Hawking, who, collaborating with Jim Hartle, suggested we could ditch the singularity by going quantum. They claim this leads to an early state of the universe, not with 3 dimensions of space and 1 of time, but 4 dimensions of space and no dimensions of time. This irons out the singularity into something more like a shuttlecock, meaning there's no boundary to the past, as there is no earliest point, just a smooth surface. Having interviewed Hawking and spoken to his daughter, I can say that out of all the brilliant ideas that he had, this was the one he was most proud of. One of Hawking's main rivals was Alex Vilenkin, whose audacious idea of tunnelling from nothing was published around the same time as the Hartle-Hawking proposal. Just as particles can fluctuate out of the vacuum, so Vilenkin suggested that space itself, if treated quantum mechanically, would also fluctuate, and here from a state with no space or time, a universe from nothing. To truly grasp what happened at the Big Bang, most cosmologists think we need a theory that marries the physics of the very small, quantum mechanics, with the physics of the very large, general relativity. In short, a quantum theory of gravity, and the leading candidate is string theory. While our book, The Battle of the Big Bang, delves into models like string gas cosmology, brane inflation, and the pre-Big Bang, perhaps the most dramatic is the ekpyrotic model. In string theory, our world is embedded in what are called branes. Now, these branes have to be partnered. They can't exist by themselves. And if they were to collide, it's thought that this would release an enormous amount of matter and radiation. A Big Bang. The brains are then thought to move apart, only to come back together. I like to think of two hands clapping. This results in a cyclic universe. String theory's main rival is loop quantum gravity, which pictures space not as a continuous fixed background, but rather a dynamic quantum network. This implies space has a maximum capacity, a bit like a sponge. If you pour water on a sponge, it will absorb that water, but there comes a point where it becomes full up, and then it switches from becoming water absorbent to water repellent. Once space is squeezed to its limit, gravity switches from attractive to repulsive. The Big Bang becomes a big bounce. Could the universe cycle between contraction and expansion? You might think dark energy, which is accelerating the universe expansion, would rule this out. But new evidence suggests dark energy might change over time, potentially becoming negative and allowing the universe to recollapse, which it could then bounce out of. Other cyclic scenarios, like Roger Penrose's conformal cyclic cosmology, don't involve any recollapse, but use other means to allow the universe to endlessly repeat over infinite eons. In relativity, black holes also contain singularities, but if these are replaced by quantum effects like a bounce, then these ultimate destroyers of matter might have a motherly side, giving birth to new universes. This could even lead to a form of Darwinian selection for the cosmos, solving a mystery as to why our physical constants seem just right for life. Some problems that inflationary cosmology solves arise from Einstein's rigid speed limit, but a newer theory of quantum gravity called Hajar-Valicious gravity proposes that as we travel back to the Big Bang, this speed limit relaxes. This could potentially remove the need for inflation entirely. It's even been linked to a dark energy proposal called Cuscaton that could resolve issues with collapsing universes, again allowing for a cosmic bounce. One of the most significant developments in modern physics is the holographic principle, which asserts that our four-dimensional universe can be described by the physics of its outer boundary in one less dimension. In holographic cosmology, as we approach the Big Bang, the dimension we lose is time, meaning our universe emerges from a timeless quantum state. This is a recurring theme among many models that suggest time and space may not be fundamental at all, but rather emergent properties from an underlying quantum system. Could the universe create itself? This idea seems insane, but bear with me. Now, if time is linear, sure, this proposal seems guilty as charged. But in Einstein's theory of relativity, there are solutions to his equations that seem to allow for a loop in time, and this could allow the universe to give birth to itself. Two variations exploit this mind-bending possibility. The Gott-Lee model, where there's a time loop at the origin of eternal inflation, and periodic time cosmology, where the entire universe is on a loop, a cosmic version of the movie Groundhog Day. So there you have it, 10 weird and wonderful ideas that cosmologists are currently exploring for what happened before the Big Bang. And if you're keen to learn more about these ideas and how we might even test them against future data, then Battle of the Big Bang is the book for you. Let me know your thoughts in the comments.